This is a thermal oil boiler. As you can see, this is wood. Source of heat is wood, and the element of heating is oil. You can see the label there. So I'm going to give you a quick overview of the operation of the boiler. So we begin with the source of heat, which is wood. This is the belt feeder, and then we have the screw feeder here. That is the screw feeder. And then we have the FD motor. So once wood gets in through the screw feeder into the furnace, has some content at the moment, you're done with heating. And heating element, oil, heat transfer oil from the reservoir up there. These are the circulation pumps, pump 1 and the backup or standby. Standby circulation pump and the main pump. So there is the line, gets into the boiler, heated and pumped to the factory. And here's the reservoir, gets pumped in up the refill tank into the pipeline. This is the exhaust system, smoke from up there. These are diffusers. I'm not sure if they are diffusers, but I'm thinking it is diffusers. And the main exhaust, and you have the ID fan. I don't know if it's the ID or the FD. So my work here is to automate the heating process of the heat source. So I want, once the set value for temperature is achieved, the induced fan and the FD fan, they should stop immediately. Options: temperature control, push button control. What the hell? What's going on? This is not right. This is completely not right. This is not okay. Wrong wiring on feeding machine and the belt. So I have found out that there are two temperatures that control the boiler. There is the downtime temperature and the feeding temperature. So I was wondering which one should I work with. And this is the thermocouple for feeding temperature. This is the sensor for feeding temperature, and up there, as you can see, is another thermocouple sensor for downtown temperature. I have decided I'm going to work with that one, that is leaving the boiler temperature of heat transfer oil that is leaving the boiler. That is the one that I'm going to use to control the induced fan and the air blower. Feeding machine and belt conveyor, they are there. I'm not going to integrate them in this automation first because our wood here is big logs. It's not chipped. It's supposed to be chipped so that it goes through up through the conveyor belt and through the screw feeder. In the meantime, we are just using the big logs directly. So these two feeders will not be automated. The induced fan and the FD fan, the air blower, are the ones that we are going to automate using the downtime temperature controller. And yeah, that's what I have done. It's a bit messy, but I'm going to arrange it later. But let me demonstrate for you what I mean. So emergency out. Let me see if the power is on. Yeah, we are on, and there are two controls. There is push button control and temperature control. We are interested in temperature control, so I'm going to switch it to temperature control. And since I'm sure the downtown temperature is not achieved yet, it is set at 250. These induced fan and air blower are going to start simultaneously. It's no problem. They won't be very high inrush current. This is a small motor. The other one is a star delta, so we are safe to start them simultaneously. So I'm going to switch it to temperature control option, and here we are. Temperature high, then it is starting. The circulation pump, I have wired it separately from the fans, since it should operate independently regardless of the temperature, feeding or downtime. Why do I keep saying downtown? It's downtime. So circulation pump will just start. That is okay, and I think I'm done with this automation. Only thing remaining is to test if, when the set value is achieved, if my fans are going to stop or continue running. If they stop, goal achieved. Anyway, stay with me. I'm going to show you in the next clip as I test this big boiler. Yep. This is the other clip that I was talking about. So you can see the boiler is on and running. This is the furnace chamber. You can see the forward draft fan pushing air into the chamber to ignite the wood. And this is where the air is being pushed through. This is the bottom of where the ash is falling, and air is pushed up through the furnace chamber. And now here is the forward draft fan. Normally pushes air into the furnace chamber. you can see the temperature indicators 76. I have preset it at 80 set value for testing. So at 80 I'm expecting the induced fan and the forward draft fan to stop, and let's see whether my automation was successful or not. At 80 I'm expecting it to the fans to go off, and now you can see it's at 79. The downtime, there it goes, and you can see the alarm is on, and the induced fan goes off simultaneously with the forward draft fan, the one labeled air blower, and you can see the temperature continues to rise. The feeding temperature is at 27, and I decided to disconnect the alarm, and since the fans are going off, there's no need for alarm. We don't need to alert anyone that the temperature is beyond the set value. So I decided to disable the alarm. Now let's see when the temperature goes below the preset value, which for this case is 80. It is expected that below 80 the induced fan and the air blower will start. It's at 79, still not started, and there it goes at 78. It has a delay of some seconds, but you can see the fans are on to ignite the fire in the chamber to raise the temperature. I was presetting changing the set value from 250 to 80, which is for testing purposes. Then later I change it back to 250, which is the operating downtime temperature. Normally located at the beginning of the furnace. The boiler operator feeding wood into is doing it manually, since we do not have wood chip at the moment. Just big chunks of wood. For now the circulation pump was off, since we needed the temperatures to rise faster and save energy.